Today, we will learn reflection and symmetry. Look here. There is a mirror line in the center of the chessboard. Suppose we place an object in front of the mirror, we will see its reflection in the mirror. Here, we have placed the object in the third square from the mirror, and we can see that the reflection of the object visible in the mirror is also placed in the third square from the mirror. What does this tell you? Think a little. Absolutely correct. Reflection appears behind the mirror at the same distance as the object appears in front of the mirror. That is, the distance of the real object from the mirror and the distance of its reflection from the mirror is equal. Like length, if we talk about angles, the angle of the reflection and the angle of the real object are also equal. However, in one aspect there is a change. The right part of the object appears to be left in its reflection, and the left part of the object appears to be in the right of the reflection. This is called lateral inversion. In such a situation, we see that the object and its reflection are symmetric with reference to the mirror line. Thus, the mirror line becomes a line of symmetry. Let's understand it more comprehensively. Suppose we draw letter A on a piece of paper. If we fold this paper from the middle in this way, we will get two equal parts of A, left part and the right part. Let us give the name PQ to the line formed by folding the paper. If we look here, the left half of A and the right half of A are exactly identical to each other. What does this tell you? Think a little. Absolutely correct. This shows us that A is a symmetric letter and PQ is a line of symmetry. Imagine that we have placed a mirror in place of the symmetric line PQ. In such a situation, the figure appearing in the mirror will be exactly the same as the half A hidden behind the mirror. Therefore, we can say that the left part of A, which is half A, and its mirror reflection are symmetric. We can also see that the distance of a point located on this half part of A to the left of line PQ and the distance of reflection of that point from the line PQ is the same. Keep in mind that here we are talking about perpendicular distance, that is, we will measure the distance from PQ at an angle of 90 degrees. Now, we can say that it is a symmetric shape or figure and the mirror line is a symmetric line. This type of symmetry, in which half of a shape is a mirror image of its other half, is called reflectional symmetry. In terms of this symmetry, we can say that the distance from the symmetric line of reflection of a point and the distance from that point to that symmetric line are the same. Keep in mind that a shape can have only one mirror line or symmetric line, and some shapes can have more than one symmetric line. In our everyday life, reflection symmetry has proved to be useful in many fields such as art, sculptural art, textile technology, design creations, architecture, etc. Let us understand this with some examples. The Taj Mahal is a famous example of architecture. In this, we see the use of reflection symmetry. Symmetry is also seen in items or objects used in our daily life. It makes the object look attractive. Do you know what a kaleidoscope is? A kaleidoscope is an instrument made using 3 or more mirrors in which a variety of attractive patterns can be seen. Many reflections are formed by mirrors that have several lines of symmetry. A rangoli is a suitable example of symmetry. While making rangolis, unknowingly, reflective symmetry is used. Observe the rangolis made during the festival and note the use of symmetry in them. Have you tried to make symmetrical shapes with paper? If not, do try. For this, take a piece of paper and fold it in half lengthwise. Then, draw half part of a pattern and cut it. Once you unfold the paper, you will obtain a full shape. If you fold a paper twice and cut a shape, you will see a symmetric pattern. So today, we learned reflection and symmetry. We will see some examples related to this in the next video. Today, we will see examples of reflection and symmetry. Draw the following figure on a squared paper and make a reflection on the other side of the given line. Imagine that there is a mirror in place of AB. As you know, in a mirror, the right part of the object appears on the left and the left part on the right, but the lengths and angles are equal. For our convenience, let's name multiple points in the figure. Here, we see that the T lies on the mirror line, so tell us where will its reflection be? Think a little. Absolutely correct. Its reflection will be on the mirror line. Let us mark this with T prime. Point P is 4 squares away from the mirror line and T is 2 squares below. In the same way, we will count 4 squares on the right from the mirror line and we will mark P prime, which is 2 squares above T prime. Q is 5 squares down from P, so we will mark Q prime 5 squares below P prime. Similarly, we will mark the reflection of R as R prime, the reflection of S as S prime, and the reflection of T as T prime. By connecting them in sequence, we will get the reflection of the figure as P prime, Q prime, R prime, S prime, T prime. Example 2. In the word geometry, can you tell me which are the letters whose reflection will not be identical to the original form? Imagine we place the word geometry in front of a mirror. In such a case, we see the right part appears to the left and the left part appears to the right. This is what we call as lateral inversion. Here, we can see that even after reflection, there is no change in the form of the English letters O, M, T, Y. That is, their shape remains identical to the original form even after reflection. But if we talk about the English letters G, E, E, R, etc., then their right part appears to be left in the reflection and their left part appears to be right in the reflection. Therefore, we can say that the shape of the letters G, E, E, R will not remain identical to the original form after reflection. So today we saw examples of reflection and symmetry. Today, we will see some misconceptions related to reflection and symmetry. Misconception 1. Find the reflection of the given figure in the mirror line. Some students fail to understand the concept of reflection. In order to write the reflection of the left side, they copy it as it is and select option 1, which is wrong. Some students write the reflection in an inverted position, that is upside down. This gives them the answer as option 2, which is also incorrect. Some students are well aware that the right part of the object appears to be left and the left part of the object appears to be right in the image, but they use this understanding incorrectly and they first write C, then B, and then A. This gives them option 3, which is also incorrect. The correct understanding is that the distance from the mirror line of any point located in front of the mirror line is equal to the distance from the mirror line of its reflection. Let's talk about C. The farther this point is from the mirror line, the farther we will make its reflection. Similarly, let us take one more point. its distance from the mirror line will also be equal to the distance from the mirror line of its reflection. Similarly, we can make the reflection of the figure located on the right in this manner. That is, option 4 is the correct answer. Misconception 2. Find the reflection of the given image in the mirror line. Some students don't pay attention to the mirror line while finding the reflection. They ignore the mirror line and believe that the reflection of the image is given correctly in option 2. But option 2 is incorrect. Note that the tilted mirror line affects the tilted reflection, but the method of obtaining reflection is the same. That is, we will find the distance of the arrow from the mirror line of the lower part and mark its reflection at that distance. Then, we will find the distance from the mirror line of the upper part and mark its reflection at the same distance. Now, we connect the 2 points. This will give us an accurate reflection of the figure. So here, the correct answer is option 1. Therefore, when you find the reflection, always keep in mind the mirror line. So today, we saw some misconceptions related to reflection and symmetry.